Good morning, students. Review exercise 6, question 2, part A, part 1. Convert 255 degrees into radians. 255 degrees equals 255 multiplied by pi over 180 radians. This is further equal to 17 over 12 pi radians. Part 2, we have to convert 75 degrees and 45 minutes into radians. 75 degrees and 45 minutes equals 75 degrees plus 45 over 60 degrees equals 75 degrees plus 0.75 degrees equals 75.75 degrees. Let us convert 75.75 degrees into radians equals 75.75 multiplied by pi over 180. This much radians. This is further equal to 101 pi over 240 radians. Question 2, part B, part 1. Convert 17 pi over 24 radians into degrees. 17 pi over 24 is equal to 17 pi over 24 multiplied by 180 over pi. Pi cancelled with pi. This is further equal to 127.5 degrees this is equal to 127 degrees plus 0.5 degrees 127 degrees plus 0.5 multiplied by 60. When we multiply it by 60, it will become minute. 127 degrees plus 30 minutes. So it is equal to 127 degrees and 30 minutes. Part 2, we want to convert 7 pi over 12 radians into degrees. 7 pi over 12 equals 7 pi over 12 multiplied by 180 over pi. Pi cancelled with pi. Answer comes to be 105 degrees. Question 3 part 1. Prove this trigonometric identity. Left hand side equals sin theta over 1 minus cosine theta. Sin theta over 1 minus cosine theta multiplied by 1 plus cosine theta over 1 plus cosine theta. That is multiplying and dividing by 1 plus cosine theta. Numerators will be multiplied together. Sin theta into 1 plus cosine theta over 1 minus cosine theta into 1 plus cosine theta. This is further equal to sin theta into 1 plus cosine theta over 1 minus cosine theta into 1 plus cosine theta is equal to 1 square minus cosine theta square. A minus b into a plus b is equal to a square minus b square. This is further equal to sin theta into 1 plus cosine theta over 1 minus cosine square theta. Sin theta into 1 plus cosine theta over 1 is equal to what? Sin square theta plus cosine square theta is equal to 1. So putting the value of 1, that is sin square theta plus cosine square theta. So we replace 1 by sin square theta plus cosine square theta in the place of 1 we have written sine square theta plus cosine square theta. Here comes minus cosine square theta plus cosine square theta cancelled with minus cosine square theta. Here comes sine theta into 1 plus cosine theta over sine square theta. This is further equal to sine theta into 1 plus cosine theta. Sine square theta can be written as sine theta multiplied by sine theta. Cancelled. In the numerator 1 plus cosine theta, in the denominator sine theta. This is right hand side. Therefore, LHS left hand side is equal to RHS right hand side. Hence proved. Question 3 part 2. Prove this trigonometric identity. Left hand side sine theta into cosecant theta minus sine theta is equal to sine theta. Cosecant theta can be written as 1 over sine theta minus sine theta is equal to sine theta. LCM is sine theta. Here comes 1 minus sine theta into sine theta is equal to sine square theta. Sine theta cancelled with sine theta. 1 minus sine square theta. 1 can be written as sine square theta plus cosine square theta. 1 can be written as sine square theta plus cosine square theta minus sine square theta. One can be written as, we know that sine square theta plus cosine square theta is equal to 1 minus sine square theta. Sine square theta cancelled with sine square theta. This is further equal to cosine square theta. Cosine square theta can be written as 1 over secant square theta, which is the right hand side. Therefore, left hand side equals right hand side. Hence proved. Question 3 part 3. Prove this trigonometric identity. Left hand side equals cosecant theta minus secant theta over cosecant theta plus secant theta. This is further equal to cosecant theta can be written as 1 over sin theta minus secant theta can be written as 1 over cosine theta divided by cosecant theta can be written as 1 over sin theta plus secant theta can be written as 1 over cosine theta. LCM of the numerator, which is sin theta into cosine theta. Sin theta cancelled with sin theta, here comes cosine theta minus cosine theta cancelled with cosine theta, here comes sin theta. Similarly, taking LCM of the denominator, which is sin theta into cosine theta, sin theta cancelled with sin theta, so here comes cosine theta plus cosine theta cancelled with cosine theta, here comes sin theta this is further equal to cosine theta minus sin theta divided by sin theta into cosine theta. Divided by cosine theta plus sin theta cosine theta plus sin theta over sin theta into cosine theta. Sin theta into cosine theta. This is further equal to cosine theta minus sin theta over sin theta into cosine theta. Division changed into multiplication, reciprocals, sin theta into cosine theta over cosine theta plus sin theta. Cancelled, cosine theta minus sin theta over cosine theta plus sin theta. In the numerator, taking cosine theta as common. Cosine theta common, here comes 1, here comes sin theta over cosine theta, because we have taken out cosine theta as common. In the denominator, taking cosine theta common, within the bracket cosine theta common, here comes 1 plus sin theta over cosine theta, because you have taken out cosine theta common. cosine theta cancelled with cosine theta. It is 1 minus sine theta over cosine theta is equal to tangent theta. This is 1 plus sine theta over cosine theta is equal to tangent theta. This is equal to right hand side. Therefore, left hand side equals right hand side. Hence proved.